Hello, aloha, sawadika, mabuhay, and a wonderful day to all of our dearly beloved learners. My name is Jeffrey T. Kadungog, and I am your teacher, broadcaster for Mathematics 10, Clusters 1 and 3. I am expecting you, in as much as I'm expecting myself as well, to be very, very excited of the things that you and I are going to learn for today in our class. What are these lessons that you are going to learn? Do you have any idea? Well, for the most part, I'm going to tell you that we are going to learn about arithmetic sequences, arithmetic means, and arithmetic series. Previously, you have learned about generating patterns as well as illustrating arithmetic sequences. Today, specifically, you'll be learning about three things. First, you are going to determine the nth term of a given arithmetic sequence. Second of all, you are going to determine the means of an arithmetic sequence. And last, but certainly not the least, find the sum of a given arithmetic sequence. Before we get to move on to our first topic for today, let us have a brief review of what you have learned last time. So, can you guess what is between these numbers to make the sequence an arithmetic sequence? 6, blank, 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 and blank, 66. You got all of those, students? Now, these are the guide questions. First, how did you guess the number or the numbers in between those numbers or terms? Second question that you are going to reflect on is that, why do you think these sequences can be considered as arithmetic sequences? Third question, can you find the sum of the sequences that I have just made mention of? Okay, now let's move on to our first lesson for today. That would be finding the nth term of a given arithmetic sequence. How do you find for the nth term of a given arithmetic sequence? For example, in an arithmetic sequence 4, 7, 10, 13, 16, and so on, what must be the 7th term? What about the 10th term, the 20th term, and the 100th term? We have a solution. You may have your own solution and you can solve that manually. But yeah, it is very easy for you to answer finding the 7th term or the 10th term of the said sequence. What about if I may be asking you the 20th term? What about the 100th term? And your teacher in class would say, answer this in just about 5 or 10 seconds. Can you possibly do that? The answer is always a yes. Now here is our solution. To find the 7th term, we only need to use the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d. Again, it's a sub n equals a sub 1 plus the quantity of n minus 1 times d, where a sub n is the last term or the nth term, a sub 1 is the first term, n is the given number of terms, and d is the common difference. I know that you already know what the common difference is last time when you talked about arithmetic sequences. Now, how are we going to use that in our solution? First, finding the 7th term. You can have it as a sub 7 equals the first term in our sequence is 4 plus the quantity of n minus 1. N will be substituted by 7 and multiply it by the common difference of 3. How did you get the common difference of 3? Simply subtract the first term from the second term. On our given, it's 10 minus 7, and that would be equal to, good, is 3. So 4 plus 7 minus 1 times 3, you get what? Yes, you get a 22. Are you now ready for the second question? I'm sure you are. Let's proceed to finding the 10th term. Be with me as we solve this next problem. A sub 10 would be now equal to 4 plus the quantity of 10 minus 1 times 3. And that would be equal to, voila, it's 31. Very good. Now what about the 20th term? If you're asked for the 20th term, so that would be very easy. A sub 20 is equal to 4 plus the quantity of 20 minus 1 times 3. And that would be the answer? The answer is, 61. And finally, in finding the 100th term, A sub 100 would now be equal to 4 plus the quantity of 100 minus 1 times 3. And in 3 seconds, you will get the answer, and that would be a 301. You got all of those? Yeah, sure you did. Now, what about if a certain question is given in a word problem or is stated in a word problem form, such as this one? Find the 25th term of the arithmetic sequence 3, 7, 11, 15, 19, and so on. How are we going to answer that question? Simple. All we need to do is to substitute the given in our formula. So the 25th term would be A sub 25 is equal to the first term in the given sequence, which is now 3, plus the quantity of n minus 1, where n is 25 as the total number of terms, times the common difference d, which is now 4. And what would be our 25th term? You got it right. It's a 99. Now that you know how to determine the nth term of a given arithmetic sequence, we are now ready to use what we have learned in finding arithmetic means. But what is an arithmetic mean in the first place? Arithmetic means are just but terms between the first term and the last term of an arithmetic sequence. Example, insert 2 arithmetic means between -2 and 7. Again, insert 2 arithmetic means between -2 and 7. So list the given. A sub 1 is equal to -2, while A sub 4 is equal to 7. The total number of terms is 4, and you are tasked to find A sub 2 and A sub 3, the second and the third terms respectively. How exactly are we going to do that? First, we are going to look for the common difference d. Why? As you may have noticed, if we just have the common difference d, or the value of our d, it's very easy to add up from the first term, then add for the next term, and so on, in order to complete the sequence. In finding for the common difference d, we are going to use the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d. Our a sub n here will become a sub 4. Our a sub 1 is, yes, we are given to be negative 2. Plus, our n has been identified to be 4 minus 1 times your d. Our a sub 4 here is 7 equals negative 2 plus 4 minus 1 gives you 3 times your d. It now becomes a 3d. When you substitute, when you transpose, negative 2 to the other side, it will become 7 plus 2. Notice that the sign has changed from negative now to being positive. Equals 3d. 7 plus 2 gives you 9, and that is equal to 3d. Dividing both sides by 3 gives the equation 9 over 3 equals 3d over 3. Canceling 3 on this side of the equation leaves behind your d, and 9 over 3 gives you a 3. What are we going to do with this d to be equal to 3 then? Simple. All we have to do is to add d, which is equal to 3, on the first term, which is negative 2. So we have negative 2 plus 3, and that will give you, very good, it's positive 1. So we are ready to put positive 1 as our second term. And to determine the third term, we're going to continue with positive 1 plus our common difference d, which is equal to 3, giving you 1 plus 3 to be equal to 4. How do we know then if our answer is correct or not? All we have to do is to check when you add 3 as our common difference to our third term, does it give you our fourth term, which is 7? Let's do that. 4, which is our third term, plus the common difference 3 is equal to 7. And since it is equal to 7, then the two arithmetic means between negative 2 and 7 are positive 1 and positive 4. Are you now ready for the next example? I'm sure you are. So here is the next example. The second term of the arithmetic sequence is 24, while the fifth term is 3. Find the first term, or a sub 1, and the d, the common difference. Again, the second term of the arithmetic sequence is 24, and the fifth term is positive 3. Find a sub 1 and d. The given are the following. A sub 2 is equal to 24. A sub 5 is equal to 3. But in this particular example, since we do not have yet the a sub 1, we will assume a sub 2 as our a sub 1. Hence, a sub 1 then becomes 24, and a sub 4 will now be positive 3. We are now ready to use the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Substituting the values would give us 3 is equal to 24 plus the quantity of 4 minus 1 times the d. Ever wonder why it's only letter d that's left to be a letter or a variable? You're right, because d, or the common difference, is the one thing that we are going to look for first. And in solving that, we will have d to be equal to negative 7. So, from 3 equals 24 plus the quantity of 4 minus 1 times d, we will simplify first 4 minus 1, giving us a 3. Multiply that to d, and we will have a 3d. The equation now becomes 3 is equal to 24 plus 3d. Transposing 24 to the other side, you will get 3 minus 24 is equal to 3d. 3 minus 24 gives us a negative 21, equal to still a 3D. Negative 21 equals 3D now is our new equation. Dividing both sides by positive 3, leaving behind D, we will have negative 21 divided by 3, and your D now is equal to negative 7. Now that we have the common difference of negative 7, we are now ready to substitute that in the same formula in order for us to get the a sub 1. This time, the original a sub 1. So, we may use and substitute the following given. A sub 5 is equal to a sub 1 plus the quantity of 5 minus 1 times negative 7. This time around, we will use a sub 5 to be equal to 3 equals a sub 1, which is the thing that we are looking for, plus 4 times negative 7. So the equation now would be 3 is equal to a sub 1 plus 4 times negative 7. 4 times negative 7 will give us a negative 28. Negative 28, when transposed to the other side of the equation, becomes 3 plus 28 equals a sub 1. And what would be our a sub 1 now? You've got it right. A sub 1 is equal to 31. Very good. At this juncture, I know that you already are very well versed in using the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d in looking for the nth term of a given arithmetic sequence, and of course, in finding some arithmetic means. I'm sure that you are now ready to venture on our next lesson, which is all about arithmetic series. From arithmetic sequence, now it is termed arithmetic series. Now, what could arithmetic series be? Arithmetic series is simply the sum of the arithmetic sequence. Again, arithmetic series is just but the sum of the terms of an arithmetic sequence. It was discovered by a German mathematician in the person of no less than Mr. Carl Friedrich Gauss, when one time he was asked by his teacher in class to find the sum of the numbers 1 to 100 in order to keep him busy. And the teacher was shocked because in a few minutes he was able to get the answer. And how was he able to get the answer? Because he found out a shorthand method using these formulas. The first formula is S sub n equals n over 2 times the quantity of a sub 1 plus a sub n, where S sub n is the sum of the first nth terms of the said sequence, n is still our total number of terms, a sub 1 is our first term, and a sub n is our nth term, or most of the time it's the last term. We have another formula. S sub n is equal to n over 2 times the quantity of 2 a sub 1 plus the quantity of n minus 1 times d. Again, it's S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. S sub n is once again the sum of the first nth terms. N is the total number of terms. A sub 1 is our first term. N is the number of terms. And D is the common difference. Now, what do you think is the difference between these two formulas? When can we use each of them? On what particular instances that the other formula is much better to use than the other? In order to answer that, let's take a look at some of these examples. The first one is, what is the sum of the first 10 terms of the sequence 14, 19, 24, and so on? First, we are going to list the given. We have a sub 1 to be equal to 14. The total number of terms is 10. The common difference can be obtained by subtracting 14 from 19. So we have 19 minus 14 equals 5. And then we are now ready to find our S sub 10. Substituting it in the formula, S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. S sub 10 now would be equal to 10 over 2 times the quantity of 2 times 14 plus 10 minus 1 times 5. Simplifying this will now give you a 365. S sub 10 is equal to 365. Therefore, the sum of the first 10 terms of the sequence 14, 19, 29, and so on is 365. The next question is, what is the sum of the arithmetic sequence negative 16, negative 20, negative 24, and so on until negative 40? Again, it's negative 16, negative 20, negative 24, and so on until negative 40. First things first, we are going to write the given. A sub 1 is equal to negative 16. A sub n is equal to negative 40. The common difference d is equal to negative 20 minus negative 16. And what do we have? Yes, it's a negative 4. Substituting these values onto the equation a sub n equals a sub 1 times the quantity n minus 1 times d, a formula which is very much familiar to you already. Negative 40 is equal to negative 16 plus the quantity of n minus 1 times negative 4. Simplifying this will give us n to be equal to 7. Next, we are now ready to look for the sum of these terms by substituting it in the formula S sub n equals n over 2 times the quantity of a sub 1 plus a sub n. S sub n now becomes S sub 7 equals 7 over 2 times the quantity of negative 16 plus negative 40 equals negative 196. All of you got that? Very good. Therefore, the sum of the arithmetic sequence negative 16, negative 20, negative 24, and so on up until negative 40 is just but a negative 196. Now that you already know how to find the arithmetic series or to find the sum of a given arithmetic sequence, let me ask you then, since we are already in the so-called Burr months, so we are now entering the season of Christmas, which we Filipinos are very much known for. In the song 12 Days of Christmas, how many gifts did I receive from my one true love on the 12th day of Christmas? Do you have any wild guess? Can you solve that mentally? Or you can still manually use that using the formulas which you have just learned? To answer that question, we need to use the formula S sub n equals n over 2 times the quantity of a sub 1 plus a sub n. Why? Because this is the illustration. On the first day, I received one gift. On the second day, I received 2 gifts from my one true love. On the third day, I received 3 gifts, and so on, so that on the 12th day, I received 12 gifts, just on the additional 12 gifts. The question says, how many gifts did I receive from my one true love on the 12th day of Christmas, if we're going to sing the song? So continuing, S sub 12 now is equal to 12 over 2 times the quantity of 1 plus 12. 12 being the total number of terms from 1 to 12, 1 being our first term, and 12 being our last term in this particular example. 1 plus 12 gives us a 13, 12 over 2 gives us 6, so that when you multiply 6 by 13, S sub 12 will be now given to 78. Go. 12 over 2 times the quantity of 1 plus 12. 12 being the total number of terms, 1 is our first term, and 12 is our last term in this particular song. So 12 over 2 gives you a 6, 1 plus 12 is 13, so that 6 multiplied by 13 gives you our S sub 12 equals 78. This means that on the 12th day of Christmas, I received a total of 78 gifts from my one true love. Question, would you also like to receive 78 gifts from my one true love? Sana all, my one true love.
Sana all na ay uyab dito sa gawas. Basta kwartahan pangit ka, sugtun ra ka. Sana all hitsuraan ko okay kayo. Guwapa, puti, sexy pa, lamig kayo.
The next question that I would like you to answer would be, a pandemic has reached a country, such as the COVID-19 situation that we are all in today. In a certain hospital, it was reported that on the first day, there were 5 cases. The second day reported 8 cases. Third day were 11 cases. Fourth day were 14, and so on. If this pattern continues, how many cases will there be after 14 days? First things first, again, we shall be writing the given. A sub 1, or the first term, is 5. Our common difference can be obtained by subtracting the first term from the second term. A sub 2 minus A sub 1, which in this case is 8 minus 5, giving us with a 3. Your total number of terms n is equal to 14. We are asked for the S sub 14. Now, the formula to be used in order for us to solve this problem is S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. S sub n now becomes S sub 14, which is equal to 14 over 2 times the quantity of 2 times our a sub 1, which is 5, plus the quantity of 14 minus 1 times 3. 14 over 2 gives us 7, right? Meanwhile, 2 times 5 gives us a 10. 14 minus 1 is equal to 13 multiplied to 3. 7 times the quantity of 10 plus, we obtain 39 from the product of 13 and 3, giving us 7 times the quantity of 10 plus 39, where 10 plus 39 is equal to 49 multiplied by 7. S sub 14 now is equal to 343. Did you get the same answer as I did? Correct. This only means that after 14 days, the total number of cases reported in that very hospital is 343. After answering the question on the pandemic, what comes into your mind then? Should we just have to not think of what the government is doing for us? Should we not just have to help our frontliners in their efforts to curb or flatten the curve? I'm sure that you know how important is to stay safe during these times. Let me just reiterate to you the safety measures that were already told to you several times, not just on TV, not just on radios, but of course by your beloved teachers, your classmates, your peers, and your parents or anybody in the family. First, always wear face masks and face shields. Second, keep distance or follow social distancing, about 1 meter or 2 meters away from each other. Avoid touching your face, your nose, your eyes, not even your ears. Instead, you should do frequent hand washing with soaps and other disinfectants such as alcohol and other stuff. Always clean and disinfect surroundings. And finally, you just have to observe proper cough etiquette. At the end of this day, I am pretty sure, apart from being pretty, that you have learned 3 things. First, finding the nth term of a given arithmetic sequence. Second of all, using the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d to determine the arithmetic means of an arithmetic sequence. And lastly, using the formulas s sub n equals n over 2 times the quantity of a sub 1 plus a sub n, and the other formula s sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d to find the sum of the terms of a given arithmetic sequence, what we now know as arithmetic series. Ladies and gentlemen, this has been your Sir Jeffrey Kadumog, your teacher broadcaster for Mathematics 10 Clusters 1 and 3. God bless and have a good day. Kapungka!